Three identical particles are joined together with the help of a thread. All the three particles are moving in a horizontal plane. If the velocity of the outermost particle is V0, the ratio of the tension in the three sections of the string will be equal to. Now it is given that if I redraw this diagram, let the center be over here. Let this be the first particle, let this be the second particle, and let this be the third particle. Now it is given that all three particles are identical. It means that if the mass of the first particle is m, the second is also m, and for the third also it is equal to m. Now let me start with the outermost particle over here. For the outermost particle, there is only one tension which acts in the left hand side direction. Let the tension be equal to T1. Okay, there is only one force that acts in the left hand side direction. If it revolves in this direction, there will be only one force which acts in the left hand side direction. It will be equal to T1. Now the distance of the third particle from the center of revolution, it will be equal to 3 times L. So basically over here, the tension in the first particle T1 will be equal to m omega square L, which is equal to m omega square 3 times L. Okay, basically it will be equal to m omega square 3 times L. Now why am I taking the value of omega square? Because the omega will be same for all three of them, but the velocities will be different. Okay, if I consider for the second particle, the second particle, the same tension will act over here. It will be equal to T1 in the right hand side, and T2 will be another tension which acts in the left hand side direction. So if I draw the free body diagram, there will be two forces which acts on the second particle m. Okay, and its distance from the center, it is equal to 2L. So basically over here for the second particle, there is one force which acts in the left hand side direction, which is equal to T2, and there is one force which acts in the right hand side direction, which is equal to T1. So basically T2 will be greater than T1 because the resultant centripetal force is in the left hand side direction. So T2 minus T1, which will be equal to m omega square r, which is equal to r over here, which is equal to 2L. So basically T2 minus T1, the T1 over here is equal to m omega square 3L. So it will be equal to 3m omega square L will be equal to 2 times m omega square L. So T2 will be equal to 5m omega square L. Okay, this is the value of T2. Now for the third particle, again over here similar to the second one, there is T2 acting in the left hand side direction and there is T3 acting in the right hand side direction. So the free body diagram will be formed somewhat like this. Its distance from the center will be equal to L. So basically if I write down the equation, the kinematical equation or the force equation for the third particle, T3 will be in the left hand side direction, which will be greater than T2 because the centripetal force is in the left hand side direction. So T3 minus T2 will be equal to m omega square r, which is equal to m omega square L. Now you can clearly see that T2 is equal to 5m omega square L. So 5 plus 1, which is equal to 6m omega square L, 6m omega square L. So T1 is equal to 3m omega square L, T2 is equal to 5m omega square L, and T3 will be equal to 6. So the ratio will be equal to 3:5:6, which is option number D over here.